All right, welcome you guys. This is Coach Orsak, and today we're going to go over the properties of rectangles, which can be found on page 9 of our notes. All right, so let's go ahead and look at this first part. If you notice that rectangles are going to have the same properties as parallelograms, those are what those first 5 bullet points are explaining. So we're going to go ahead and take what we've previously learned about the properties of parallelograms and apply them with rectangles as well. But we're also going to add these two additional properties with rectangles. And the first one is going to be that all 4 angles are going to be right angles. And the second one is going to be that diagonals are congruent. So let's go ahead and apply these new properties that we've learned about rectangles to question number 1. All right, so number 1, let's go ahead and fill out what we know first. All right, so we know that according to one of our properties, opposite sides are going to be congruent. So if I know that side PQ is 24, SR is also going to be 24 because they're opposite. And if side PS is 10, side QR is also going to be 10 because they're opposite sides of each other. All right, so let's go ahead and fill that piece of information. QR equals 10 and SR equals 24. All right, now let's go ahead and find what SQ is. All right, and if you recall, all four angles are going to equal right angles, which are going to form a right triangle. And the best way to find the missing side of a right triangle, especially when you're given 2 sides, is Pythagorean theorem, okay, which is a squared plus b squared equals c squared. Okay, so we're going to go ahead and apply that, which in this case is going to be 24 squared plus 10 squared equals x squared. That x squared is SQ, what we're trying to find. So let's go ahead and do 24 squared plus 10 squared. And we're going to add those, and we're going to get 676, which equals x squared. And we're going to go ahead and take the square root of both sides because that will cancel that squared. All right. So when we take the square root of 676, all right, we can put that in our handy dandy calculator. All right. And we are going to get the answer of 26. All right. So let's go ahead and fill in SQ with 26. Again, we use Pythagorean theorem there to help us find what SQ is because they form a right triangle. All right, so let's go ahead and find PR. All right, we know that diagonals are congruent. So if SQ was 26, PR is also going to equal 26. All right, this next one, QT, is half of SQ. Okay, we said SQ was 26, so half of 26 is going to give us 13. All right, so now let's go ahead and look at number 3. All right, if you notice number 3, we are going to be trying to find different angle measures. All right, this first one, we're trying to find MJK. All right, well, one of the properties that we just wrote down is that all 4 angles equal right angles, which is 90 degrees. So which is why MJK is 90 degrees. All right. Now, this next one is asking for MJL. All right. Well, if we know that each corner is 90 degrees, right, because that's one of our properties, all right, to find what MJL is, all we're going to do is 90 minus 27 because we know that this angle is 27. All right. And we're going to go ahead and get 63. So MJL will equal 63 degrees. All right, this next one is asking for the measure of angle JLK. All right, now if you notice about JLK, this is a property. All right, they're going to be alternate interior angles because if you recall, these lines are parallel. Okay, so we use one of those properties. They're going to be alternate interior angles. And if you remember, if they're alternate interior, they're going to be congruent. All right, so if MJL was 63, JLK will also be 63 degrees because they are alternate interior angles. All right, so we got 2 more. Let's check out the measure of angle KML. All right, well, KML, all right, if you notice here, all right, is that since we know the diagonals are congruent, all right, that's why I put these blue little lines, all right. If you notice here, okay, this is kind of like a throwback, all right, this is going to create an isosceles triangle, okay, because these sides are going to equal the same. All right. Now, if you remember our isosceles rule, all right, they are going to have the same, if the two sides are congruent, they're going to have the same base angles. Okay, so if this side is 27 degrees, the other base angle is also going to equal 27 degrees. All right. Now in purple, if that base angle is 63 degrees, since it is an isosceles, it does form this, all right? The other base angle is also going to equal 63 degrees. All right. So go ahead and we are going to we also know that they form 90-degree right angles, so that's why the angle right here in purple is also 27 degrees. So that's what KML is going to equal. All right, so 27 is going to be the measure of KML. All right, let's check out this next, our last one, trying to find the measure of MNL. All right. Well, we know that the other base angle of this triangle, MNL, all right, since it does form an isosceles, all right, this other base angle is going to be 27 degrees, okay? And we know that all three angles add up to 180 degrees, okay? So all we have to do is add 27 plus 27, and we're going to get a total of 54. And we just subtract 54 minus 180. All right, and we are going to get a total of 126. Okay, so that's what that missing measure. All right, you guys, so let's go ahead and look at number 4. No, it says number 6 on here. Okay, so on page 9. All right, so we're trying to find what EF is. All right, well, we know one of our properties of rectangles is that opposite sides are congruent. So we know that side CD is going to equal side EF. Okay, so we're going to go ahead and set those two sides equal to each other, all right, to help us solve for X and then solve for EF. All right, so let's go ahead and write those two expressions down. All right, we're going to go ahead and get X equals 11. All right, but the question is asking us to find what EF is. All right, so we're going to go ahead and plug 11 back into the expression for EF. All right, so we're going to do 7 times 11 minus 39. All right, you get your handy dandy calculator out. All right, and that expression is going to equal 38. So EF will equal 38. All right, so let's go ahead and look at number 9 on our notes, okay, which says number 11 on here. So again, it's going to be number 9 on our notes on page 10. All right, so we're going to do one with degrees here. All right, now this question is asking us to find the measure of angle JHL. Okay, well, if you notice, it's given us these two angle measures. All right, and one of our properties for rectangles is that these two angles are going to equal 90 degrees because they form a right angle. All right, so we're going to go ahead and add these two angles together. All right, so 3x plus 2 plus 12x minus 17 is going to equal 90 degrees. All right, so from here, we're going to go ahead and solve for x. All right, so now we're going to go ahead and try and find the measure of angle JHI. All right, and we know that these two lines are going to be parallel. All right, and that's actually going to form an alternate interior angle. All right, so let's go ahead and write that down, that the measure of angle GJH is going to be equal to angle JHI because they are alternate interior angles formed by two parallel lines. All right, so to find that missing angle measure, JHI, all right, we're going to go ahead and plug that x value into what GJH is, which is 3 times 7 plus 2. All right, and that's going to equal 23 degrees. Sorry, I had to change my pen there. All right, so again, since they are alternate interior angles, all right, they're going to be congruent. So if GJH is 23, all right, JHI will also be 23 degrees.